Hello there. Today we are going to find the Fourier coefficients. Find the Fourier coefficient A0 and Am for the function f of x equal to pi minus x by 2 the whole square in 0, x. So the solution is, first of all, here's the formula for the Fourier series of f of x. The Fourier series of f of x is of x equal to 0 by 2 plus epsilon n equal to 1 infinity a of n cos nx. This is the formula for the f of x in Fourier series. Now let's see what's given. We are given that f of x equal to pi minus x by 2 the whole square. So that's equal to pi minus x the whole square by 4. Just squaring it. Now let's find out a0. It's 2 by 5 integral of 0 to pi minus x by 4. And x the whole square by 4. So let's take out the 4 out from 4 is a constant, so take out from the integral. So 2 by 4 pi 0 to pi, let's square this. It's in the form of a minus b the whole square, so it's a square plus 2 plus b square minus 2ab. And we have our dx. Now let's cancel out this 2. Goes 2 times in 4. And then now it's 1 by 2 pi. And we integrate that, so we get pi square x plus x cubed by 3 minus 2 pi x squared by 2. Zero to pi. Integrate that with respect to x. So the x has power and the same number divides the numerator. So we get 1 by 2 pi. Now we are applying the limits. So the numerator minus the denominator. So we apply pi for x and then 0 for minus 0 for x. So we get pi cubed by 3 minus 2 pi squared by 2. Minus 0 minus 0 plus 0 minus 0. So that's 0, obviously. And then we have to multiply these numbers, these pi's. So it's pi cube and then pi cube plus by 3 minus 2. Let's cancel out the 2's. So we get pi cube again. So it's plus pi cube or minus pi cube. So we cancel out each other. 2 pi and then multiplied by pi 3 by 3. So let's cancel out this pi and it goes in 2. So we get pi squared by 6. Okay, this is a0. Now we have a0. Let's find out an. That starts like this. 2 by pi. We enter integral with 0 to pi limit. Pi minus x the whole square by 4 and cos n x dx. So okay, let's take out the 4 out. So 2 by 4 pi into 0 to pi. Let's square this. square minus 2x pi and cos n x dx. Then let's cancel out this. So 1 by 2 pi 0 to pi square x square minus 2x pi cos n x dx. Okay, now we are going to use Bernoulli's formula. Let's try it in another page. Using Bernoulli's formula, we get an equal to 1 by 2 pi and then that number in the previous equation minus 2 pi x and then sin nx by n. Now see it like a UV, we do an integration. So we are integrating with respect to x, of course. It's 2x, it's 2x minus 2 pi. And then, okay, let's see how this came by seeing this. While integrating, this is while differentiation, this is 2x and then 2 pi because this becomes 1. This number doesn't have a x code, so it's 0 while differentiating. So 2x minus 2 pi. That's what here. And then we're going to integrate this cos n x dx. So we get minus cos n x by n squared plus 2 plus sin n x by n cube 0 pi. Now in this equation, this one and this one will become 0. So we get 1 by 2 pi. So it looks like 3 finger, but that's okay. 2x minus 2 pi cos nx by n square. So if these two terms become 0, then this is what we get. And this minus and minus will become plus. So there's no minus. And then 1 by 2 pi 2 pi minus 2 pi, because now we are applying the limits. It's first we apply pi for the x and minus subtract from that 0 applied to the x. Cos nx by n pi by n squared minus 2 of 0 minus 2 pi cos n of 0 by n squared. Now 2 pi minus 2 pi cancel out each other, so this term becomes 0 again. So we get, and this also becomes 0. So this minus and minus will become plus. So we get 2 pi this cos n of 0 by n squared. So in the next step 1 by 2 pi, it's 2 pi cos n of 0 will become 1 by n squared. So 2 pi will cancel out each other and we get 1 by n squared. And that's the an. And then therefore the Fourier series is a0 by 2 plus, now we have to apply the values for a0 and an. So by applying we get, let's see what's the value for a0. A0 is the value pi squared by 6. So we get 5 squared by 6 into 2 and equal to 1 infinity. That is for a n is 1 by n squared. So it's 1 by n squared cos nx. So this becomes pi squared by 12 plus n n squared by cos nx. This is the value for f of x in the Fourier series. Okay, that's it for the video. Thanks, bye.